Welcome viewers. In today's lecture series, we will study about the topic entitled Plastic Pollution Management. Firstly, we will go through the objective of our lecture, which are as follows. Number 1, to understand the importance of plastic in this modern world. Number 2, to study the composition, processing techniques, and the harmful effects of plastic in the environment. And thirdly, to analyze the various strategies beneficial in plastic pollution management. Now, the word plastic had originated from pliable, that can be defined as easily shaped. Plastics can be conveniently modified from one shape to another based on their desired functionality. Plastics are also known as polymers, or a long chain of monomers which are bonded to other identical subunits to form a polymer. Polymers can be of natural origin, such as cellulose as the basic subunits that make up plant cell walls and helps the cell to adapt their function. Cellulose is known as one of the most abundant biopolymer on Earth. The first synthetic polymer was discovered around 1869 by John Wesley Hyatt. It was highly expensive as compared to polymeric materials. By properly treating the cellulose polymer derived from cotton fiber with camphor, John Wesley invented a plastic that could be changed into various shapes and made to reproduce natural substances including linen, horn, and tortoise shell that could be useful in plastic production. Now, is plastic an important commodity? Due to their remarkable physical and chemical characteristics, plastics have become a major commodity worldwide and have several applications in commercial and industrial products. However, the use of plastics with many harmful environmental impacts related to their production and poor methods of waste treatment. Around 9% of the generated wastes are recycled, which was a very minute quantity compared to the total production. Approximately 80% of the generated wastes were reported to accumulate in landfills or in the natural environment. Under different circumstances, ultraviolet light can decompose plastic into their monomeric constituents, including microplastics, which are highly complicated and almost impossible to recover, and disrupting food chains and disturbing human and environmental health. Bakelite was initially discovered in 1909 as the first fully synthetic plastic, which was not natural as cellulose. Bakelite has more use and benefits rather than insulators of electric cables. It was also heat resistant, durable, and unlike celluloid, ideally suited for mechanical mass production. Now, plastic as a packaging material. Packaging is one of the most important and frequent application of plastic materials. About 40% of plastic materials worldwide are used to stock and package finished products from different factories. Plastics had a significant contribution in creating a sustainable, proper, hygienic, cost-effective, energy-efficient, and environmentally friendly packaging system that can keep the environment clean. The versatility of plastic has provided an efficient proof of hygienic and cost-effective packaging of food products like bread, rice, snacks, juices, spices, milk, edible oil, wheat flour, and confectionaries, and various types of pharmaceutical products. Due to increasingly high application, these products generate huge post-utilization waste burden on the environment. Various categories of plastics include polyvinyl chloride, polystyrene or styrofoam, polypropylene, high-density polyethylene, polyethylene terephthalate, and others. Now we come to the composition of plastic. Plastics are primarily composed of binders, fillers, pigments, plasticizers, and other additives. The plastic object from human cultural heritage are material testimonies of our technology and history. The binder gives the plastic its primary properties, and commonly its name is also based on binder molecules. Binders may be both artificial and natural materials like casein or milk protein or cellulose derivative. However, most of the binders are synthetic resins. Polyethylene is widely used in the production of plastic materials. It can also be defined as a polymer of ethylene with this structural formula and empirical formula respectively, and is produced at a high temperature and pressure depending on the desired properties of the final product. Polyethylene is resistant to acids, water, alkali, and most organic solvents. Different classes of plastic can be categorized into thermoplastics and thermosets based on their physical and chemical properties. Thermoplastics are the class of plastics that can be melted and molded by heating and hardened by cooling. They can be reheated, reshaped, and hardened repeatedly. This plastic quality also makes them mechanically recyclable, which is a good method of waste management. Thermoplastics can be categorized according to their structural organization, like chemical bonds, and the level of their properties and functioning. Now we come to some of the plastic processing methodologies. Plastic processing refers to the series of steps that transform polymers or plastic raw materials into final products that can change the standard of human life in different dimensions, including financial, health, and development. Now, the major use of plastic is directed in beverage and food processing factories. Some synthetic chemicals known as additives are added to improve durability, applicability, and modification of plastics. These additives that can help in the modification processes are bisphenols and phthalate plasticizers. There are several methods of processing polymer to high-quality plastics. These methods are classified into three main categories. Firstly, the primary processing methods, which are transfer molding, compression, extrusion blow, and injection. Secondly, we have the secondary processing methods, which are calendering and fabrication, roto-coating, thermoforming, coating and casting. And thirdly, tertiary processing methods, which includes welding, drilling, bending, and cutting. Now, the harmful effects of plastic wastes. Plastics are useful in daily life in different communities. Its post-use can change different parameters of the world if not well managed. Some of these effects could be harmful to the environment, including human beings. Before the management of plastic waste, it is important to elaborate on some of the harmful effects which the poor management of the plastic can cause after utilization. Non-biodegradability and poor waste management can cause series of environmental hazards to safety and choking of the drains in urban cities and other production areas. These physico-chemical properties of plastics contribute to their usefulness, and their waste after utilization are thrown away. their durability advantage, which supports their usefulness, and wastes after utilization. They are thrown away, their durability advantage, and in the municipal solid waste counted under 10 to 12% of the plastic residue is combusted. After the combustion process, the gases are released into the environment, which increases the air pollution and causes greenhouse effects. The substance released in the atmosphere are furans, dioxins, and polychlorinated biphenyls. Now, the main concerns regarding plastic waste are immediate measures and implementations are needed to address and manage them properly, which can protect the environment. It is also applied in an aqueous environment for aquatic and aquaculture protection since many of these contaminants are hydrophobic. Plastic in the aquatic environment is potentially acting as a sink for contaminants, which makes them less accessible to wildlife, particularly if they are buried on the seafloor. The poor disposal and plastic waste mistreatment effects are categorized under three main classes, including the effects of plastic waste on animals, public health, and environmental pollution. Now, with this, we come to our first quiz. The question is, synthetic polymer was discovered by number 1, Nestra King, number 2, John Wesley Hyatt, number 3, Robert Hooke, and number 4, Rosemary Ruther. The correct answer is John Wesley Hyatt. Plastic waste management. Plastic wastes are rapidly produced and exposed at a high rate due to the world's industrial development and population growth. Both biodegradable and non-biodegradable wastes are highly generated from man-made activities and natural processes of living creatures. Government, municipalities, social communities, and local authorities have established different measures and environmental safety legislation that can guide the population to dispose of plastic waste after utilization. In these waste management strategies, several are scientifically based, such as recycling, incineration, bioremediation, and landfills. These methods are established to have a clean environment and good plastic waste disposal. Now we can learn about the various scientific strategies to manage plastic waste. First, we will come to recycling. Recycling refers to the waste management method which collects waste materials and converts them into raw materials that can be reused to form other valuable products. It is also known as renewing or reusing to prevent the harmful effect on society and environmental protection. The plastics are non-biodegradable as carbon-based products and other polymers. It contains bottles and other materials that can be melted and transformed into other products like plastic tables and chairs. The process is performed in the following 6 steps: collecting waste plastic, sorting or arranging plastic into categories, washing to remove impurities, shredding and resizing, identifying and separating plastics, and compounding. There are several benefits of plastic waste recycling that the world can gain when plastics are reused rather than disposing of them in non-desirable places. The protection of human life by decreasing carbon dioxide and other harmful gases in the atmosphere, which can occur during incineration or combustion of the waste. Recycling reduces pollution across ecosystem, requires less energy, and helps in natural conservation. It saves fast depleting landfill space and eases the demand for fossil fuel consumption. Moreover, it promotes a sustainable lifestyle and contributes to the national economy. Although recycling has different benefits to the community, it also has some disadvantages that can be managed and controlled. During the recycling process, some chemicals are released into the environment. Among these chemicals, some are volatile gases that come from plastic waste composition, an organic chain of monomers that build up a plastic chain of organic fumes and ashes which kill plant structure and affect wildlife when inhaled by different animals that live near the recycling zone. As the process requires heat to melt plastic, it also generates sulfur, carbon, and other gases emitted to the environment. These gases can cause global warming, greenhouse effect, and acid rain that harms the environment in different ways. This can also lead to health issues for the population who are crossing the plastic recycling zone. After the plastic downcycling process, wastes are separated for continuous recycling, which explains how it ends up with plastics is generally unfit for another round of recycling. This means that it ends up in a landfill rather than regarding them as a secondary use of unconsumed plastic waste. Next, we come to incineration. The waste incineration method refers to the burning of waste in oxygen, which is chemically known as complete combustion, that releases water molecules and carbon dioxide into the atmosphere. The waste produced after incineration is composed of different volatile chemicals, ash, and a small amount of hydrochloric acid. Generally, all plastic waste is not a good candidate for combustion. Some are resistant to oxygen heating and explosives. It is not an obligation that incineration can be used to treat all household waste plastic types properly. To select plastics to be incinerated, we must be careful on non-combustible waste to avoid these unprepared explosive accidents. The combustion of organic molecules can also produce energy, which is known as fuel. The fuels can be presented in different physical states like liquid, solid, or gas, which is used by the vehicles and airplane propulsion. The method of incineration has several different positive impacts on society rather than energy production. It also has a huge contribution in minimizing the waste and producing electricity from the waste, which is highly needed in modern industrialization. Waste incineration has played a critical part in producing renewable energy from biomass resources. Incineration, including heat recovery, was used in a different part of the world and more than 450 times in Europe. There are several benefits of plastic waste management through incineration, which includes decreased quantity of waste in the ecosystem, produces heat and power needed in different activities, reduces pollution of the atmosphere, saves economy on transport fee of the waste, and emolites harmful germs and chemicals. Moreover, it can be applied in any season or weather and prevents the production of methane gas. Incineration as a chemical process has benefits and drawbacks like all other biochemical processes or scientific processes. Some of the disadvantages of the incinerating process include expensive setup compared to other waste management methods. It pollutes the environment and can damage public health. It releases ash waste that can harm people and the environment. Next, we come to landfills. Plastic disposal post-utilization in different dustbins end up in landfills. Landfills refer to all places and areas where we reject all disposable plastic waste after utilization before being buried under the earth's surface. Through this manual disposal process, many precautionary measures should be applied to avoid secondary side effects like groundwater contamination and soil degradation that can result from poor processing. The objective of landfill arrangement are to provide a safer area of plastic waste disposal to protect all dimensions of the environment, that is, the aquatic and airspace, to achieve the objective mentioned above. It demands a lot of work be done in the community, like digging a long hole or dumping in high depths and putting waste into it and letting them decompose. This process is completed very slowly, as it can take more than a year. During this landfill processing, each organic molecule passes through biodegradation and decomposition. Plastic bags and other long polymer waste can take around 10 to 100 years to degrade in landfill processing. Different plastic waste can take a long time of degradation due to their specific biochemical properties and environmental or climatic conditions like sunlight, wind, and climate change without these main driving factors. Therefore, the first selection or choice for disposing of all plastic products must be reused or recycled. Landfills are an excellent energy source due to the carbon dioxide and methane gas produced during the biodegradation process. It keeps the city clean, hygienic maintenance, and segregates hazardous waste from other type of waste. Moreover, this is cost-effective method of plastic waste management. Although this method can be used to treat plastic waste, it has some disadvantages, including being partially responsible for climate change and lighting up methane as a combustible gas. It contaminates the soil and water and affects the wildlife. Next, we come to pyrolysis. Pyrolysis refers to the process of converting gases and fatty oils to recover crude petrochemicals and obtain hydrocarbon. It is even used to recover crude petrochemicals and generate renewable energy from plastic waste. Pyrolysis process is classified into three main categories according to the amount of heat energy needed to destruct the plastic connections. There is high temperature, medium temperature, and low temperature based media. Medium and high temperature are based on the range of temperatures used to destroy the plastic structure. The corresponding temperatures defining the pyrolysis states are in the following ranges of less than equal to 600 degrees centigrade, 600 to 800 degrees centigrade, and higher than 800 degrees centigrade respectively. Thermosets and thermoplastics are the main category of the most used plastics in humans' daily necessity, where about 80% of the used plastics are all thermoplastics. This is based on their easy ability for molecular reformation under heat treatment and their suspensibility to change. The products resulting from the pyrolysis of plastic, depending on different factors like reactor type, residence time, plastics, condensation arrangement, feeding arrangement, and the temperature applied. The crude oil derivative plastics are modified to its monomers and other useful component, example additives and plasters, classified into the first derivative of petroleum refining cuts, and petrochemicals through catalytic means of chemical treatment or thermal effects. These chemical treatment principles were initiated for good management and proper accumulation of plastic waste in the waste management industry. This scientific method is an efficient manner of waste management, even though it may require high capital cost. Lastly, we come to bioremediation. It refers to the process where microorganisms can decompose waste. Bioremediation can also be defined as the branch of biotechnology that has the main principle towards detoxification and decontamination by using microorganisms to biodegrade all natural compounds that can be treated under biodegradation of plants, algae, fungi, and bacteria. It needs different conditions for culture medium like nutrients, enzymes, pressure, and temperature, which all needs to be settled at an optimum level to facilitate the growth of microorganisms. In the bioremediation process, enzyme as a chemical catalyst work by reducing the activation energy and converting the substrate into the product. The enzymes are most likely to be used in the process, including microbial oxidoreductase, microbial oxygenase, lactase, peroxidase, microbial lignin, hydrolase, and microbial manganese peroxidases, microbial lipases. Plastics like polyvinyl chloride under natural degradation result in the monomer of phthalates like vinyl monomers, dioxins, and CFCs. Now, with this, we come to our second quiz. The question is, which of them is not a technique of plastic waste management? Number 1, recycling. Number 2, pyrolysis. Number 3, chemical decomposition. Number 4, bioremediation. The answer is chemical decomposition. Now, to conclude, plastics positively impact our daily life due to their basic applications in household activity and industrial packaging of various end products. Although plastic have several important roles in our life due to their physicochemical composition, they can cause different problems to human life and the ecosystem if the post-use disposal is not well managed. We have tried to understand the different methods that can be applied to treat plastic waste so that the plastic life can be cyclic. The application of these methods will save the lives of people, animals, and the environment by saving a lot of money by recycling raw materials and reusing plastic. In addition, it is crucial to keep the environment safe. This will keep everyone living in this ecosystem to spend a safe and healthy life. The recycling of plastic waste will help to improve the economy by decreasing the production cost. Not only economically viable, but also will help to eradicate infectious diseases that are transmitted through polluted air and water.